read properly? Okay, let's go. So I have two canisters. Like always, I have my dfx.json file, I have my invoice.mo and secret.mo. So it represents my main.mo. In the, in the other cases, we had just one file, so it was main.mo, but this time it's invoice.mo and secret.mo. And so we have two canisters. The first one is the secret canister, which is here. It stores a password, and this password can only be accessed to users that paid. And to verify payments, we have a mechanism of invoices. And so we have an invoice canister where you can create invoices. So each invoice has an ID, which is just a number, invoice 0, invoice 1, and so on. Each invoice has a status. So for the status, I'm using a variant type in Motoko, which is a type that can be either this one or this one. This is how you define a variant. So an invoice is either paid or unpaid. And then an invoice is defined by a status and an ID. I have a buffer to store the invoices, and then the invoice canister can be used to create invoice, checks the status of invoice by giving the ID, and to pay invoice. To pay invoice, we don't really actually involve any money. So we could build like a token and a ledger and everything, but for the sake of this example, it's just essentially calling pay invoice is everything you need to actually pay. And then in the secret canister, we actually need to call the invoice canister because we want to know when a user called the function getPassword, is this user someone that has already paid an invoice? If it's the case, then we can reveal the password. If it's not, we don't reveal the password. So this session is about intercanister calls, and we will see why are intercanister calls so important. Well, we've seen in this quick example that sometimes you need actually information and data that is located in other canisters. And that's absolutely essential that we can call other canisters on the internet computer, because this is how you create composable services. For instance, how does OpenChat, let me show you, how does OpenChat actually works? They work with intercanister call. So you can see that here, I can go in the Motoko Bootcamp chat, and I can use this to send ICP. I can send chain key Bitcoin. I can send all the tokens that exist on the IC, chain key Ethereum, and so on. How is it possible? It's possible because under the hood, the ICP ledger is connected with the OpenChat application. So OpenChat is going to send a message to the ICP ledger. And that's how, well, that's not actually the best example, because I don't think there is intercanister call involved. It's just calling directly the ledger. Maybe what would be a better example, I think it's that you can swap token, if I understood correctly. Let me see. Yeah, you can swap actually token for another currency. And so this is going to call another canister. And to swap, you are going to involve many canisters, because you will have to call the ledger canister for the token ICP and for the token, in this case, nuance. So if you're switching from token A to token B, you need to call the two canisters within your swap canister. There are many other use cases, like, for example, when I verify your canisters on the Motoko Bootcamp dashboard, I send a call to your canister and I verify a few functions, and that's from my dashboard canister that I do that. So it's an intercanister calls. Intercanister calls are super important for so many reasons, and so that's why we are seeing them today. how to import a canister in our code. Actually, this is very simple. There is a really simple syntax. It's very simple and very similar to importing any other function or modules. What you need to do is define let actor invoice. So I'm going, or maybe canister invoice. I'm defining a variable just like any other variable. Then you need to use the keyword actor. Here you need to specify the canister ID. So right now we don't have it because we haven't deployed our canister yet. So right now I'm going to leave that empty. And then actor, so this is the type. The type is actor, and you need to list all the functionalities that you want to call on this canister. So let's say we want to call create invoice. So create invoice. Oops. Create invoice is a function that takes no parameter and it returns an invoice ID. So we would need to specify that the type, we need to import the type invoice ID. So invoice ID is a NAT. And maybe we also want to do we also want to do check status. So check status is a function that takes an ID, as you can see here. And it returns an invoice status, an optional invoice status. Oops, it's like this. Of course, we need to import the type invoice status. So in public type invoice status. And I can just copy paste what I have on the invoice canister. So here, I will format. Okay. So this is how you import another canister. You specify the canister ID. Canister ID will be, in a few moments, I will put it. Then you specify the interface. And notice that I actually don't specify the whole interface. I only specify the methods that I need. So I need this one in my code, like you see here. I need the create invoice and I need the check status, but I don't need the pay invoice. So I'm not listing pay invoice here, even though I could, I don't need to do it. Okay. Now we need to replace, so we need to replace it here. So let me show you canister invoice and canister invoice. We are calling those functions directly by using the variable. So this is how you can call it. You do await canister invoice, so the name of your variable, then create invoice. So you just call the methods. And this will, from this canister, this will call this other canister. Notice that we have to await because this is a asynchronous operation. So we have to await. If you don't await, it will throw an error saying that this is a promise and you need to await on it. This is how you call create invoice, and this is how you call check status. So same thing, same syntax, and same, yes, same working. It works the same. So now I will deploy, I will start a replica, so locally. I will first deploy my invoice canister because I need the ID to have in the secret canister. So dfx deploy invoice. there is a question about what if we don't know the types? If you don't know the types that you are calling, it's very, well, you cannot really call another canister if you don't know the types that are used in this canister, or at least the public types that you are calling. You could do, it's called like a one-shot call. You could just call a method and not expect any results. But in the case or where you are expecting something back from the canister, you need to know what is the type that is coming back to you. If you don't, you won't be able to use it. So this is my canister ID for the invoice canister. And so I can use this here. Oops. And now I'm able to deploy the secret canister. Okay, so let's play with the Candid UI. Okay, so this is the Candid UI for my invoice canister, and this is the Candid UI for my secret canister. So I will first create an invoice, and I will receive my invoice ID. So this is invoice number 0. Then I can check the status. So it should be unpaid. Okay. And now I will try to call this canister, the secret one, to get the password. Okay, so it looks like it has created another invoice for me, which is not what I was expecting, but yeah, so let's see. Okay, so your invoice has not been paid. So I have a new invoice, apparently. It's invoice number 1. It's unpaid, of course. And so I cannot access the password. I can try again. If I pay here, so I will pay the invoice. Okay, this is paid, apparently. Now I can try from this canister and I should receive the password. And I received the password, which is 42 for some reason. And so, as you can see, we have leveraged this canister status, like the fact that the invoice was paid in this canister. And so that's how you would do it. Another question, is there a way to extract defined types from a canister if I only know its canister ID? Or must I have like a candid file from that canister? Yeah, so that's my next topic. How to access information on other canisters. So in this example, it was really easy, or at least it was doable because I am the controller of both canisters. I have the code here locally, so I can just copy paste and there is no problem. What if I don't own the canister or I don't know too much about this canister? Then you can use the dashboard, and there are multiple ways to go about that, but dashboard is one. And you can actually check interfaces of other canisters. So let's say, for example, let's say the canister of the bootcamp. It's a good example because it's a live canister. It's on the internet computer. And so I just need to check. Okay, this is my canister ID. And so this is how you can access another canister. And I can actually see all the methods on the canister. And so there is a Candid UI. So Candid here, you can just copy that. It's a Candid file. You could have it in your file. Or you could also use Motoko interface. So in that case, we have all the types use in the canisters. And we have the interface of the canister. So for example, I could just copy that. Oops. And try to code it. So let's say I'm creating another canister called example. And let's say I want to get the stats. So I will only use the stat method, the rest I will not use. So I need to know what is the stat types. And we can see here that it's statistic about the usage of the dashboard. So number of users, number of graduates, number of students, and number of projects. So this is public type self is maybe not public type, or maybe let's bootcamp canister is equal actor, and then we have a canister ID, and then the interface, which is get stats. Okay, and let's copy paste the canister ID. So this is not a very interesting method, of course, because what we are doing here, and I need to add my example canister. So it's not a super interesting example because it's just like what I'm doing here is I'm using one canister to call the bootcamp canister and get back the statistics about the activity of the bootcamp canister. But of course, we could do more things. We could process some, we could store the data locally. We could run some functions on it. It's just an example of how you would call another canister that you don't know about. And so let's use the Candid UI again. So we are calling our canister, and then our canister is calling the bootcamp canister. So it can take some time to answer. It depends on the availability and the availability of the subnet. And so we get statistics. So we have 250 users, 33 graduates, 109 students, and 328 projects. Is there a way to programmatically get that metadata from within a canister? Yes, you can you can do that. So there is something called the meta. So how do you access that? How do you access that? I know that it exists. I don't know how to access it though. Okay, so it's okay. It is possible because so the question is, can I access the Candid interface of another canister from this, from the canister code, like from here, essentially. And there is something called canister metadata. So it's a bit hidden in the documentation. But essentially in the system state tree, so it's very complex, but it's how the IC is exposed. You have access to some information, and you have access to, for example, canister information. So users have the ability to learn about canister information like the module hash, controllers, and the metadata. And so the metadata can contain the ICP candid interface, which contains the encoded candid interface. But this is only accessible if you use a HTTP request. So you would have to use an HTTP request from within this canister to access the certified state tree of the IC and then get the information. I believe it should be easier. There should be pretty soon a way to access it natively, like from the IC itself. Because right now I think it's a lot of work to get it, but it does exist and it's possible. Is it possible to run update functions on other canisters also, or only query functions? No, you can call query and update function, but you can only do canister calls from an update function. Like we could not do this, so we could not do uh, we couldn't call a query or another canister from a query function. This will throw an error, which is misplaced await. You cannot use any await in a query function. So I will add it to the README. Current metadata and query updates calls. What is preventing DDoS attack? What is preventing a vampire DDoS attack from intercanister calls? What if my canister calls update calls another canister to spend their cycles? So yeah, that would be a problem. But actually, it would not be efficient for anyone to, you know, try to do that. So you have a lot of ways to block who can call your methods. Like for example, you can in your code. I can show you, for example, the bootcamp canister. If I can go back to the interface that I had. Like for example, remove admin is a function that you could call on my canister, but if you do that, you will see that you cannot actually. Call was rejected, canister trap explicitly, because I have a mechanism to verify when you call. If I can find my source code, it's here. Like remove admin So the first line of the code is assert color is equal to master. So master is the master admin of the canister. And so if you are not the master admin, I refuse to, you know, um, to remove it from the to go even execute those lines. Like those lines are not even executed. So it's yeah, essentially it's it's trapping here. So it's getting out of the execution of the canister. And it doesn't even consume almost zero cycles for me. So you could try to spam some methods, but I can also block some of my methods first. And then if you want to DDoS a canister, I think you really don't want to do it from another canister, like because the intercanister calls actually are costly, so reasonably costly, like you can use them. But if you were to spam intercanister calls, you would very quickly empty your cycles, and the caller is the one that is going to pay for the execution of the intercanister for the intercanister calls cost. So you would pay more than you would be able to damage my canister. But DDoS attack on canisters are a real issue. It's called cycle drains attack. And it's one security issue, but there are many, many ways to prevent that. For example, assertion, like blocking some methods from being called by certain users is one thing. I could also block all the methods of my canister. I could block them by, for example, checking the first line if the caller is a student or not. If it's not, then I just trap. I could do this as a protection layer, you know, that would be good. And you can also do rate limiting. So if you see that someone is calling your function like 100 times an hour, you could also block that. What if I meant, what I meant was, can I call update functions of other canister? Yes, you can call update function of other canisters. This is, you can call query function and update function, but you can only do that from an update function of your canister. Color is equal to master would be like the Ethereum only owner modifier. Yes, this is something I've defined myself, so I can actually show you. When I deploy my actor for the first time, I have essentially the principle of the person deploying the canister, so me in this case, that is stored. Color is equal creator. I call that yeah, the creator of the canister. And then I have an admin module, and I store the master admin and then a list of admins. So master admin is a stable variable that I store forever. And then I check that actually, yeah, I use remove admin. I check that. And then it's in admin module. So the admin module, uh, when you want to add an admin, yeah, I also I also was thinking about that, but actually it's okay because I have a check here. So I have sub modules that essentially will always check that only admin can add other admin. But yeah, maybe I should add it just for the clarity next time. Uh, so a function on my canister define and implement as a query plus insert canister is more expensive than calling just an update function. Yes, definitely it's more expensive because you have to pay for the cost of the intercanister call and the cost of the function. So Intercanister. Intercanister. It's here, yeah. So for every intercanister call, you have a specific cost that is associated. Then, of course, if you send more information, like if you send a lot of bytes, for example, if you have a long argument that you send to another canister, this is also going to cost more. And generally, yes, calling a function from a canister is going to be more expensive than calling it just from a regular like user identity or agent. So yeah. That's approximately what I had on intercanister call. Uh, then it's mostly about, finding your canister, finding the interface that is here. And then you can play with it. You can try some methods. I think one canister that is interesting to play with is the ICP canister ledger. So the canister ID, you can find it. Well, I have this topic that I always go to. You have some of the, I would say, like system canisters. So those are interesting because you can see how they are built, and you can interact with them. For example, this is the ledger. And so you can see that you have the methods to, check the account, decimals, archive. The ICP token implements a standard called ICRC1, which is the token standard. And you can see how all the methods, so maybe Motoko. So you have all those methods that you could play with and try to, experiment with the ICP ledger. Okay, well, we are about everything I wanted to see on intercanister call has been done. How are intercanister calls, how are NFTs implemented on the IC? Well, we have 20 minutes, so I can talk a bit about it, but well, essentially you would just, the standard on NFT is a bit like, it's a complex space. We have many different standards. But essentially, I've worked on an NFT project. I've used the EXT standard, which was one of the first one to came out. You would just store, like a traditional contract on Ethereum. You would just store it in a canister. And you could also have the assets of your NFT directly in the canister. So this is an NFT project. If you want to take a look at it, it's interesting. It's a 1-year-old code base, so things are moving so fast that I think it's not the best like implementation that you can find today. But essentially, it was a dynamic NFT collection following the EXT standard. So the EXT standard is still here, and yeah, it's 2 years old now, so starts to be like a long time ago. But essentially, you had a token identifier for each NFT, and then just like a map between users and token identifiers. You would able to do transfer, approve, and so on. And I think right now there is an NFT standard which took some time to come out, but for many reasons, it's coming out now. And it's the ICRC7, which is a standard for tokens, for NFT, non-fungible tokens. I don't know where is the standard though, if it's already out there. I haven't had time to look into it. Okay, and so that closes our session of Intercanister call. I see everyone in 2 hours. We have the session on building the level 3. Good luck. See you.